Woohoo! We're live. This is Math 60, Intermediate Algebra, Section 6.2, page D. And we are still multiplying. And yes, these are suddenly numbered. These are more deluxe than the first page. And again, I have no idea how I choose where to number things and not. So I apologize for that. But let's go ahead and do some work. So first one out. I've got 1 over x times y over y plus 1. So I look at this and I see that I've got a y plus 1, I've got a y, I've got an x, I've got a 1. And then I remember the rule, which is these two y's are like winking at each other. They're like, hey, hey, hey there. And the answer is no, they can't be reduced. Why? Because why can't they be reduced? That's funny. Y plus 1, there are two terms down here, which means danger, Will Robinson, do not reduce unless you can factor something out of this. And in fact, y plus 1, the only thing I could factor out is 1, which will not help us. So this should be seen as a single piece. If it doesn't cancel completely, you can't cancel it. So if I look at these things, I say, oh, there's nothing that can be canceled. I cannot reduce. So I'm going to multiply across the top. I get y on top. And I get x times the quantity y plus 1. And here we come up to the place where I get cranky with my colleagues. But don't tell them. Remember, close the boxes or else those little critters will escape. I believe that factored form is the proper form. I don't think there's any reason to multiply out. Your final form for fractions or rational expressions should be the factored form. However, many answer keys and other folks will insist that you multiply out. By multiply out, I mean in the denominator. This is silly. In the very next step, you're going to have to factor so you can do whatever the next thing is that's going to happen. So honestly, I think this is a better form, but just know that it's possible someone might be wrong. And just for the record, professors don't like being called wrong. So just say, my previous professor just did it differently. And then under your breath, you say, they're always right. So you must be completely mistaken. Doctor, whatever, so-and-so. Okay, let's do another one. Ooh, this one looks almost identical, but this is very exciting. Oh my goodness, look, yes, it's true. There's an X in the bottom. There's an X in the top. We can cross cancel or reduce or however you like to think of it. They reduce completely. And notice that when I reduce something completely, I leave a 1. It's a good practice so you don't get confused because up on top, all you have left is 1 times 1. Down on the bottom, 1 times the quantity y plus 1. So all I've got is 1 over y plus 1. Bam. By the way, this step that I did right here, totally unnecessary. You can go right from here to here if you'd like. Okay, next up. Again, I prefer simple death. I don't think this one's the death one. I actually think the next page, which we're going to do, this one's the death one. So I'll leave that till later. But this one is a slightly, I know that one escalated quickly. This one escalated quickly. So here I've got a situation I'm going to write really big for my poor little eyes. And I hope by now you have come up with a clever way to distinguish your 2's from your z's. You'll notice I do cross my z's. That's because my 2's look surprisingly like z's sometimes. Okay. So this is just going to be a free-for-all. I double check. Each of these has a single term. There's no pluses or minuses. So I am free to cancel everybody. Cancel Palooza. And there's a lot of stuff that gets canceled here. So you may want to take your time. And so I'm going to start with the numbers because I find the numbers easiest. 5 goes into 5. It goes into 20. 6 and 9. 3 goes into 6 twice. 3 goes into 9 3 times. You'll notice this mess is why I always rewrite the problem so that I've got a clean version of the problem. In case this goes tragically wrong, I can always come back here and see what I had originally. So if you've been wondering, why do you write everything over again? That was why. So I always have this one that I can refer back to. Okay, now you could keep going. Personally, when things get too messy, my eyes are not that good. So I'm going to go ahead and just regroup with who I have. You don't have to do this. You also are allowed to do this anytime you want. When you've reduced, you can take a breath and then see who's left. And I see I've got some Y's. I got a Y up here and two Y's down here. So I'm going to cancel this Y. And then I'm going to do a sneaky, lazy thing. I'm going to cancel the square, which is not considered, that's considered rude by some people, but other people think it's just fine. And that would be me. Let's see, Z's. I got 4 up here. I got 7 down here. So if you'd like, you could just cancel the 4 up here. You had 7. 4 of them are canceled, so you're left with 3. That's that subtraction. 7 minus 4 is 3. Now, if you would like, it is also possible just to write them out. If you're feeling unsure, you guys see this? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4. You can kind of see it happening. 4 Z's. Cancel top and bottom, and I'm left with 3 down on the bottom. You can always do it that way. Lots of different styles, lots of different methods. And then let me see if I can read my own writing. 4 3z cubed times 2 over y. I get 8 over 3yz cubed. I also did something, I played fast and loose with order there. Alphabetical order is generally considered what do you call it? Polite. So if you can get in alphabetical order, definitely do. Okay, we're only at 6.5 minutes, so I say let's march on till death. Half a league, half a league, half a league onward into the valley of complicated division problems rode the 500. Was there a man afraid? I can't remember most of it. My understanding is people in the modern era, born after the 1700s, no longer have to memorize that, but we all have to memorize that and recite it. Imagine 35 students all reciting the same poem, one at a time in English class. And we didn't have phones to sneak into our classes back then. Okay, division. Division is really not your friend, but it is fine. You guys are like acquaintances and you have no trouble with each other. You just have to, you know how to deal with it. It's not overly friendly, and you know that division lies. Even though it looks like the 6 and the 9 and the Z's and the Y's and everything's going to cancel, this is division. Division lies. So remember, we switched division to multiplication, who never lies to you. And then we've got 5y squared on top and 6z to the 4th on the bottom. That would be the numerator and the denominator for you, kids that use actual language. And so I flipped it. I took the reciprocal of the second fraction flipped. See that? And now that I see this, I do see a couple things. Well, I see one thing that cancels. I don't know if y'all see it. There is a 20 and 6 share a 2. So I'm going to go ahead and cancel the 20. I try to do it with a single line so I can still read what was underneath it. I get 10y over 9z to the 7th times 5y squared all over 3z to the 4th. I get 50, 10 times 5. And then I've got y times y squared, that's y cubed, all over 9 times 3 is 27, z to the 7th, z to the 4th, z to the 11th. 7 plus 4 equals 11. I take a quick look at this. This is a bunch of 3s here. This is 5s and 2s. Nothing cancels. The y's and the z's are pairwise prime. Look at me showing off my education. And we move on. Okay, you guys ready for death? I know, this escalated so quickly. Let's give it a try. So, lots of different styles. What I'm going to say is I'm always concerned that division is lying. So my first stop is always do not collect go, do not pass through, do not pass go, do not collect $200. Change it to multiplication. You just have to. So I will do that straight up front. That's my thing. Switch the division to multiplication. Woohoo. Okay. Next up, we're going to have to factor. Again, I'm going to recommend that you pause the video right now and on your own, see if you can factor all of these. Because if we were in class, I'd say, okay, I'm going to take 5 minutes. Everyone factor the heck out of this. And then I would wait, and then we'd all discuss it and then come back in. So definitely practice this. So otherwise, when would you practice? I guess during the homework. But this is like guided. This is like a guided meditation. Imagine you're in a classroom and the teacher says, now try factoring. Okay, so go ahead and press pause now. For reals. Go ahead and do it. Woohoo. Okay. Okay, welcome back. So I'm going to go ahead and factor the heck out of everything. Why did I know to factor, you're asking me? Well, look at all those minuses and pluses. The truth is, I know I've said this before. Addition and subtraction hate you. They hate you irrationally. I know. There's no reason to hate you. You are lovely people. But addition and subtraction, I don't know. Someone was mean to them when they were young or something. They just hate everybody. And they're going to mess up everyone's fun time. And I know you learned them first and your teachers told you that addition and subtraction were easy. They're not. It was a trick. It was an evil trick. Multiplication is the one that loves you. And division doesn't mind you. But addition and subtraction, seriously, they just don't. They don't even. So what we're going to have to do is when we see these subtraction and addition, we're going to have to factor the heck out of these. Top one, y squared minus 36. That is, you're right, a difference of 2 squares. Y plus 6, y minus 6. You see why we did chapter 5 first? Okay, coming down here, you might notice that this is a perfect square, because it is, or you might notice that you can FOIL it, or unfoil it, I guess is what I should say. Trial and error. Okay, over here, this one's going to be a trial and error. It's not too hard, though. Looks like y minus 4, y plus 3. And then down here, this one's the easiest one of all. That was the last one. It's just factoring out a common factor. So, are they always going to be this easy? Well, probably not, because a lot of the time when you're going to be doing this math, I won't be sitting here telling you how to do it. If you get stuck, one thing to note is that most problems in problem sets and things that we will give you can be done. For example, if I give you a problem in the problem set, either there's no solution or it's something you're capable of. So if I've already got a couple y plus 6, y minus 6, I'm looking for more of those because they are going to set it up so they do reduce. Well, that was exciting. So I'm getting out some more handy dandy highlighters. So when you're looking for how to factor it, keep in mind that a lot of the factors are going to show up twice. Now, in this case, we only get to that it seems reduce. There's a y minus 4. And then you might ask yourself, which one of these should I choose? It's whichever one you feel like. I want to cancel that one. I know a lot of you are like, no, cancel the other one. Fine, cancel the other one. Okay, so those two cancel, these two cancel. And I think what I get is y plus 6 times y plus 3 all over 3 times the quantity y minus 4. Now, remember what I said in the last page. I said, my perspective on this is so different. I think this is a perfectly fine answer. I think a better answer is to actually multiply these out again. So it'd be y squared plus 9y plus 18. Pause the video, make sure you know how to get to that. If you're like, wait, what? Or in case I made a terrible error. But this is where I'm a weirdo because I think, oops, no, try that again. I think that we should always leave denominators. Let's see if I can fix this so when I make it. It's maybe a video of me trying very hard to use whiteout tape. There we go. Ha! Look at that. It looks beautiful. Like no one ever made a mistake there. Okay. So the truth is, I believe denominators should stay factored. I think they always should. Rational expressions you should never multiply out. Never, 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 never. So, but because I know that a lot of people, like this is a very uncommon belief that I hold. A lot of people believe that you need to multiply it back out. Well, to be honest, a lot of people in movies go into the basement when I could have told you, take stay out of the basement. I don't even have a basement. That's how strongly I believe in that one. So y squared plus 9y plus 18 over 3 times the quantity y minus 4. That's how I would do this one. But it's possible that your teacher may want that one. And again, just a reminder, professors don't like to be told they're wrong. So you just think that in your head. And on the outside, you smile and you say something like, I hope I can get an A this semester. And that's the way it works. Welcome to education, guys. It's a racket.